This video presentation is brought to you by the Pro Mathematics Academy. Moving right along to our bonus questions, right? And as per usual, we always start by simplifying. So here we want to simplify our expression, right? And in particular, we want to factorize. Let's complete that. We want to factorize both the numerator and the denominator. Okay, so here we have x squared plus 6x plus 5 divided by x squared minus 3x minus 4, which is equal to x plus 1 times x plus 5 divided by x plus 1 times x minus 4. Right? And if we look at this, we realize that we end up with x plus 5 over x minus 4, and the reasoning that we're using here is that these two x plus 1's both cancel each other since x is not equal to -1. Okay, we're only approaching -1, but we are not at -1. Okay, so now we can turn to our limit to say that the limit as x approaches -1 of that expression is equal to the limit as x approaches -1 of x plus 5 over x minus 4, right? Which is the same as taking our x plus 5 divided by x minus 4 and evaluating it at x equals -1, which now gives us -1 plus 5 over -1 minus 4. So this then gives us +4 over -5, which is equal to -4/5. Okay, and that is our answer. Moving right along to our next bonus question, we have the limit as y approaches 6, right, of y plus 6 divided by y squared minus 36. So of course, we want to simplify our expression. So in this case, we end up with what? Y plus 6 divided by y plus 6 times y minus 6. So this is then 1 divided by y minus 6. Okay, so this means that the limit as x approaches 6 of y plus 6 over y squared minus 36 is the same as the limit as x approaches 6 of 1 over y minus 6. Notice that if I sub in y equals 6, we end up with 1 over 6 minus 6, which is equal to 1 over 0, right? So note the limit as x approaches 6, right, of y plus 6 over y squared minus 36 is similar to the limit as x approaches 0 of 1 over x. So since the limit as x approaches 0 of 1 over x does not exist, the limit as x approaches 6 of x plus 6 over x squared minus 36 is equal to undefined as well. All right, so when we say that the limit is undefined, it means the same thing as saying the limit does not exist. All right, so we jump right into our next question here, which gives us the limit as x approaches 0 from the left of x divided by the modulus of x. So here we have to recall, right, that the modulus of x is the function defined piecewisely x if x is greater than 0, right, and it's equal to -x if x is less than 0. Of course, it is equal to 0 if x is equal to 0. Okay, so what do we have here? We now want to use this definition to figure out what the function x over the modulus of x looks like. So here, x over x is the first term. So here that's 1, right? If x is greater than 0, right, it seems that the function is undefined if x is equal to 0 and it's equal to -1 if x is less than 0. Okay, so now let's find our limit as x approaches 0 from the left of x over the modulus of x. Right? So from the left, we have to figure out which one of these functions, right? Is it going to be 1 if x is greater than 0? Or is it going to be -1 when x is less than 0? We have to think about what does it mean when we say we are approaching x equals 0 from the left and approaching x equals 0 from the right. So if we are greater than 0, we are approaching from the right, and here we are approaching from the left. So therefore this limit is equal to -1, right? And that is our answer. Okay, so we are approaching from the left can always be associated with x less than, okay, and approaching from the right can always be associated with x greater than. Okay, so that's something we want to make a note of. Moving right along to our next question, right, we have the limit as y tends to 4 of 4 minus y divided by 2 minus the square root of y. So here I'm just going to jump right in without any simplification, right? We have the limit as y tends to 4 of 4 minus y over 2 minus the square root of y is equal to the limit as y approaches 4 of 2 plus the square root of y times 2 minus the square root of y divided by 2 minus the square root of y. And if we look at our numerator carefully, we realize that this y that we have here is actually the square root of y squared, or it's the square of y square rooted. Okay, so if we imagine that we have 4 minus y being equal to 4 minus the square root of y squared, then we should recognize that this is 2 squared minus the square root of y squared, which now can be applied as the difference of 2 squared. So we have now 2 plus the square root of y times 2 minus the square root of y, which is what I basically applied in my numerator right here and here. Okay, so continuing with our solution, we now recognize that this limit, right, is now equal to the limit as y approaches 4 of 2 plus the square root of y, which is basically 2 plus the square root of y evaluated at y equals 4, which is equal to 2 plus the square root of 4, which is equal to 2 plus 2, which is equal to 4. All right, so that is it for this video. Please remember to hit the notification bell, like, share, and subscribe for future post notification.